Here is a second example, x squared plus 2x minus 8 equals 0. First thing that I'm verifying, my equation has to equal 0. If my equation does not equal 0, I cannot use the zero product property. So I have met that requirement. First step is to write the left-hand side in factored form. What two numbers multiply to negative 8, and add to positive 2? Those two numbers are 4 and negative 2. 4 times negative 2 is negative 8. 4 plus negative 2 is positive 2. So I'm writing that left-hand side in factored form. Not forgetting to write equals 0 because that is the equation that I'm solving. Now I know that if this factor times this factor equals 0, either the factor x plus 4 equals 0 or the factor x minus 2 equals 0. Now all I have to do is solve each equation. So my first solution is x equals negative 4. If I plug negative 4 into this equation, I will get 0. Solving the second equation, I get x equals positive 2. If I plug 2 into this equation, I will get 0. So I have solved my second example. The two solutions to x squared plus 2x minus 8 equals 0 are x equals negative 4 and x equals 2. Now something awesome about solving quadratics using the zero product property is discussed here. The solutions to the equation solved using the zero product property give me the x-intercepts of the function obtained from the left-hand side of my equation. So let's look at what that means for this example. So let's write the function obtained from the left-hand side of this example. So f of x equals x squared plus 2x minus 8. So when I look at this function, when I solve this equation, what I'm finding are the x-intercepts of this function. This function, f of x equals x squared plus 2x minus 8, is graphed right here. And you can see that, in fact, I have found the x-intercepts of this function. The first x-intercept is 2, 0, and the second one is negative 4, 0. So x equals negative 4 gives me the x-coordinate of my x-intercept. X equals 2 gives me the second x-coordinate of my second x-intercept. Notice that the reason that this is the case is that the x-intercepts are the 2 points where y are 0. So when y is 0, that is telling me that the output is 0. And that is exactly what I'm finding by solving this equation. The two input values that give me an output of 0. So f of negative 4, when I evaluate the function for negative 4, I get 0. When I plug in 2, I also get 0. And that means, again, when I solved this equation, I obtained the point, negative 4, 0, 2, 0, the two x-intercepts of the quadratic function obtained from that equation.